We're getting into some pre-algebra and algebra-like expressions here, and we're going to be doing addition of equations today. In the future, we'll be doing subtracting and also two-step equations, but today it's just addition equations. And we're going to be learning how to solve an equation with a variable in it. Let's talk a little bit about equations. An equation is a mathematical statement that two expressions are equal. So for example, I might have x plus 3 equals 7. Okay, that is an equation. It has an equal sign, it has two halves, and x plus 3 is going to have the same value as 7, so they're equal. The solution of the equation is the value of the variable that will make this statement true. Okay, so if I put a 5 in here for x, 5 plus 3 equals 7. That's not true. So 5 is not a solution. Okay? Even if I put 3 in here for x, 3 plus 3 is 6, not 7. So 3 is not the solution to this equation. The number that is the solution is 4. So the solution for this equation would be x equals 4. This is the solution. And you need the variable set equal to the value that makes the original equation true. Okay, there's going to be some steps in between that we're going to use so that in more complicated problems we'll be able to find our solution. And what we're going to have to do is isolate the variable. That means to get the variable, which is the letter in the equation, we need to get that letter alone on one side of the equation so that it's equal to the solution. And you can see here, right above here, x equals 4. The variable is alone on one side of the equal sign, and the solution is on the other. Okay? So we're going to be isolating the variable using inverse operations. Inverse operations are operations that undo something that has been done to the variable. In our original equation up here, x is having 3 added to it. Okay? So we're going to undo the adding of 3. And the opposite of adding, you all know, is subtracting. So if I have x plus 3 equals 7, I need to do the opposite of adding 3. Now there's a couple of different things that you can do and a couple of different ways to show your work here. The way that we normally use is to write underneath the equation subtract 3. The opposite of adding 3 is subtracting 3. So I'm going to subtract 3 from this side of the equation, and I'm going to subtract 3 from that side of the equation. Now, 3 minus 3 is 0. I don't need to write the 0 down here. I just need to know that this has gone away. I no longer have 3 on this side because I've subtracted. I'm left with x over here. Now this equal side means equal treatment. You have to treat each side of the equation equally. So if I'm subtracting 3 from one side, I have to do the same or equal thing to the other side, which is subtract 3. Whenever you have an equal sign in your equation and you're performing an undo, you need to do the same thing to each side in order to keep the equation equal. It's like a balance or a scale, and we'll look at that in a minute. So we have to treat both sides equally. X is the only thing left on this side of my equation. And I'm going to have that equal to 7 minus 3, which is 4. So this is how I would write the equation out and show my work. Another way that you could do it, x plus 3 equals 7. You can also write x plus 3 minus 3 equals 7 minus 3. Whichever way is easier for you to do. This can get a little confusing with the plus and minus in here. And then we would do x plus 3 minus 3 is 0, so we'll leave that off, equals, and then 7 minus 3 is 4. So those are two ways that you could show your work. inverse operations, we just talked about subtraction is the inverse of addition. So the inverse of subtraction, or the opposite, now invert, when we talk about fractions, means to flip the fraction over or make it upside down. So when we use inverse, that's a similar word, we're talking about the opposite. So the inverse of subtraction is addition. Multiplication's inverse is division, and division's inverse is multiplication. We're going to show you how to solve these problems with models, and you'll be given a key. Now we're going to remember that the equation is like a balanced scale. I mentioned that just a little bit ago. To keep the balance, to keep both sides equal, you have to perform the same thing on both sides. We don't do subtraction on one side and addition on the other. Those are opposites. We have to do the same thing to both sides. So if I subtract on the left side, I also have to subtract on the right side. In order to solve this expression, or this equation, I'm sorry, x plus 6 equals 2, I need to get rid of what's being done to x so that x will be all by itself. And what's being done to x here is adding 6. The opposite of adding 6 is subtracting 6. So I'm going to put 6 negatives on this side of my equation. Just like we did with the adding and subtracting integers, we're going to be able to make 0 pairs to cancel things out. So if I put 6 negatives on this side of the equation, my equal sign would be here. This is the equals. So now I have x plus 6 minus 6 equals 2. I have to do the same thing to this side, and I'm going to put 6 negatives here. You can see this happening in the next step down here, these next blocks. Okay, so I would drag in 6 negatives here. Okay, that gives me step 2, which is right here. I have my 6 positives and 6 negatives. I have my 2 positives and 6 negatives on the other side of the equal sign. When I cancel out my 0 pairs, these cancel, and these. X is the only thing left on this side. I have 0 pairs here and 4 negatives on this side. So negative 4 plus 6 equals 2. And x is worth, or equals, negative 4. Over here we have x plus 3 equals 5. So I'm going to pull in an x, 3 positives. When you're drawing your models, you're going to go ahead and the first block of models right here, this first set, you're going to model exactly what the equation is telling you. X and 3 positives equals 5 positives. So we're going to pull all those in. Now in our next step, our second step, you'll draw out, and you would be drawing this on your sheets, x and positive 3 again. We're going to start with the same equation. X and positive 3 equals positive 5. So I'm going to put 5 positives over here. Now, to get rid of the addition of 3 with x, so that x will be all alone, he doesn't like very many people, this x guy, so he wants to get rid of those 3 other friends he has. We're going to put a subtract 3 sign here. So we would subtract 3 from both the left and the right, do the same thing to both sides. So I'm going to put 3 negatives, or minus 3, over here. Whoops, I'm sorry, down here in step 2 this is. So I'm going to put my 3 negatives on this side. Whatever I do to the left, in order to keep my scale balanced, if I'm taking 3 pieces away from the left, if I don't want my scale to tip, I better take 3 pieces from the right also. So I'm going to put 3 negatives on this side also. And then I can go ahead and cancel out my 0 pairs. So 3 and 3, all of these cancel out. And on the other side of my equal sign, I'm going to cancel out 0 pairs. Now I have x left over here, so I'll pull down 1 x and 2 positives on the other side. So x equals 2 here. I'm just going to write off to the side x equals 2. And if you go back and fill in this 2 for the x, this is called a check. So now I have x plus 3 equals 5. Oops, it's not going to let me show it right there. I'm write smaller. X plus 3 equals 5. If I go back and fill the 2 in for x, now I have 2 plus 3 equals 5. And 2 plus 3 is 5 equals 5. So I know I have the right answer because 5 does equal 5. One thing people run into when they're doing these checks is they put this 2 back up here in the equation and they automatically assume they had the right answer, so they don't actually add the 2 and the 3. So I'll see people come down here saying that x is 3. They'll put 3 plus 3 equals 5 up here, and then they'll put 5 equals 5. So you actually have to do the math when you're checking your answer to make sure that your variable value is the right value. All right. Okay, so modeling these equations, that's that's examples number 1 and 2 on the second page of your notes. I want you to go ahead and model these out and solve them with the keys that are given to you. So on your key, a positive 1 is worth a smiley face. Negative 1 is worth a no sign. And then you've got the hourglass kind of thing for x. So I'll help you model the first one. You would draw x and 5 positives. Okay, and then you're going to put an equal sign. And then you'll pull out 7 negatives. Or you'll draw your own 7 negatives. Go ahead and do number 2 down here on this one. Number 1 was just modeling. Number 2 is to turn it around. I want you to tell me what equation this is. So up here in number 1, we turned the equation into a model. Down here in number 2, I want you to turn this model into an equation. We might not always use the same pictures to model, so you're going to have to check the key that's given to you to decide what's a positive, what's a negative, and what is x. Solving these following equations, I'm going to do number 3 and number 5 for you, and then your job is to do 4, 6, 7, and 8. Okay? So on number 3, what I want you to do is we need x to be by itself. We have to get rid of the addition of 5. So what I'm going to do is subtract 5 here and subtract 5 there. And I want you to show your work on this part. I want to see what you're adding and subtracting. Okay, that leaves me with x equals, and 8 minus 5 is 3. Okay, down here in this box, I'm going to write x equals 3 for my answer. Now for the check, I'm going to start with x plus 5 equals 8. 3 plus 5. I have x being worth 3, so 3 plus 5 equals 8. And then 3 plus 5 is 8 equals 8. And that's my check. I know I got the problem right. That was number 3. You're going to do number 4 on your own. And then let's look at number 5. Negative 3 plus z equals 8. Now our variable here is z, and so that's what we're going to use. We need z to be by itself. Now when we're looking at this, we have a negative 3, but it's still being added here, okay? But we have to do the opposite of whatever is going on. So if I have negative 3 plus z, how do I get rid of a negative 3? How do I make negative 3 be 0 so that z is by itself? And to get negative 3 to be 0, I'm going to have to put positive 3 with it. Even though there's an addition sign here, to get rid of negative 3 and make it 0, I have to put a positive 3 with it. So I'm going to add 3 to this side